Hi guys, so this is the video where I'm going to explain the answers to the free response section. I'm going to do my best to make sure that you can see all of my work, but sometimes it's hard to show the entire page, so if you need to, put the video on full screen. If you can't full screen in Edmodo, depending on what device you're using, this video is also up on YouTube. You can try it there. The first question, and this is a section where you are allowed to use your graphing calculator. The first section starts with a little description, and it says that we're talking about a situation where a fly is flying around, and we're measuring the time, and the time is the input of the function, and the output is the displacement, which is kind of like the distance, measured in meters. The first part, A, said use your graphing calculator to help you evaluate d of 2. So the first thing you needed to realize is that d of 2 basically means to take 2 and plug it into this expression. Since you have a calculator, that's just a simple evaluate thing. Now, to me, because this is a multi-part question and I anticipate using the equation multiple times, what I did was I went to y equals and I typed in the equation there. And this is what it looks like. Double check that you have parentheses around the denominator, x plus 1. I think if you plugged it in wrong, that might have been what messed you up. Once you have the equation, you can go to second calculate, and you just want to calculate the value. What value? The value where x equals 2. So I'm going to hit value. The calculator needs a second to do its little graphing thing. But once it's set, it allows me to type in 2, and when I hit enter, I get 1.594 as the value. Now that's only half the deal because you also need to explain it. So what does it mean? Well, when we plug in an x value and get out a number, this just represents the output of the function, and they told us it's measured in meters. So its units are meters, which means it must be measuring a distance. The way I phrased it is here on the page. There's a number of sentences you could use as long as you use the right units and that you conveyed that we're talking about the distance that the fly is at 2 seconds, and that's really important. It's not just the total distance, it's a specific time, how far did it get. That contrasts with B, where you're looking for the derivative at 2. Again, the graphing calculator makes this really easy because I can go again, second, calculate, and I can come down here to the derivative. When I hit enter and I select the value of 2, it tells me that the derivative is 1.166 or 167 if you round. Remember that for the AP Calc exam, you must use 3 decimal places, and you can round or truncate, either one's fine. And this is where the thinking starts. So the meaning of the derivative at the point where time equals 2 is always going to be a change statement. In this case, it's how the distance is changing with respect to time. But you can do a little better than that, because when we talk about distance changing with respect to time, something like meters per second, clearly that's measuring a speed. The meaning of the derivative in this case is speed. And actually, anytime your x value represents time, the derivative is going to represent a rate or a speed. So what this is saying is that exactly at 2 seconds, this is how fast that fly was traveling. Next, it asked you to do the algebra, find an equation. This was a chain rule. Obviously, ln's the outside function, and inside the chain rule was a quotient rule. And inside the quotient rule was a product rule. How terrible and how wonderful. And it's actually surprisingly not as much work as you might think. You can take a moment to look through mine. I'm going to point out that this is the derivative of the outside function. I plugged in the inside. And that this is our quotient rule right here, and that this right here is the product rule within it, but I'm not going to do any more explaining. Do pause the video here and think through the details, especially think about my use of a greatest common factor and my canceling, but it's just algebra, you can do it. If you successfully do that, you could answer D, and the answer is that the fly never stops flying. This is tricky. So if the fly stops, one thing we know is the derivative is going to turn into a 0, right? Because the derivative represents the speed. So how do we know if the fly ever stops? Well, if the derivative equals 0 at a particular point, that means the fly stopped at that particular time. But this expression can never equal 0. Kind of weird, right? Like no matter what you plug in the top, this can't equal 0. And that's simply because there are no numbers that are solutions to this equation. It has no real roots. If you try to do quadratic formula, you're going to get a non-real root, something under a square root that's negative. Maybe you see the algebra, maybe not. Basically, what you should be able to say is, look at this. Is there any way the top expression could be 0? And no, there isn't. Okay, let's talk about the next question. Question 2 is short and sweet, and actually people did pretty well with this. Taking the derivative should be easy. It's just power rule. Make sure you see it. And then you did have to interpret the meaning of this statement. In other words, it tells us at what values of x. So my answer is going to look like x equals, or just one of them at least. At what values of x does the derivative equal 0? Well, you don't have to guess here. They're telling you the derivative is supposed to equal 0. You have an equation for the derivative. Set it equal to 0 and solve for x. And then you've got the x values that, if you plug them back in, make the derivative 0. This was just a snowflake method right here. You can kind of see it. What does that mean? Well, if these two x values make the derivative 0, what happens to the graph? What does it mean for the derivative to be 0? It means that the tangent line has a slope of 0. What does that mean? It means the tangent line is horizontal. I recommend sketching it out if that's helpful to you. If hearing me say the words didn't compute, write those 3 things down, the things that I've said were the same, sketch it out. Second derivative is the derivative of the derivative. There's the derivative. Take its derivative again. Easy, easy, easy. Also, how cool. You learned something new on a test. Don't forget that. That's going to come back next unit. It's super important. Second derivative, it's a thing. And then if you got that far, this is kind of the same type of work as we did above, where you set it equal to 0. And then you just solve the equation to figure out what x is going to be. And make sure you simplify the fraction. Last question was a sketch, and you have a graphing calculator, so you should use it. I just typed in the original function, and I'm going to hit graph. And what you see is the original window is maybe not the best window. It's kind of visible. You can see the telltale cubic shape. But if I want to be able to mark the points where f prime and f double prime equaled 0, I want to make sure that my graph really clearly shows me -1 1/3 and -1 and -1 2/3. And so since those are all pretty close together, it would be helpful to zoom in. And particularly the y-axis seems okay, but I want to zoom in, kind of limiting the range in terms of the window x-axis. So if I go to the window, I'm going to make the window smaller just in terms of the x values. Maybe instead of -10, I'll just start at -4, and I'll go up to +4. And then this just allows me to see a little bit more clearly what's going on at these values. So this is what I would sketch. And I apologize for my messy sketch here. But the question asks you to label the point where the derivative equaled 0. And there were 2 of them, but they're both like right around here. And what's interesting is if you look at it, it's kind of clear that the graph has a horizontal tangent there, which is as it should be, because that's what it means for the derivative to equal 0. Let's look at the next question. All right, question 3, this is the non-calculator section. This was my personal favorite. I talked to a lot of you about this in tutorials, so I'll just go over it briefly. Basically, this question gives you some weird, complicated definition that may not make sense, and it expects you to kind of figure it out. And that's really typical and completely fine for the test to do. It's a test of critical thinking. And I recommend that you always try to understand some piece, and don't stress about what the big picture is. It's about building blocks off of something you do understand. So in the example, I understand that if I take the derivative of this term, the coefficient's going to turn into a 1, because when I multiply 4 times 1/4, they cancel each other out and make that coefficient. Knowing that that works that way, if I go back and read the rest, given the set of polynomials where n is an integer and a to the n are coefficients, such that the derivative has a coefficient of 1 for all of its terms, I start to get the picture. My goal here is to write a polynomial. N clearly represents the highest exponent, and it looks like the exponents count down, n minus 1, n minus 2, all the way down to where there is no exponent. So they're going in order, and they're counting down, 4, 3, 2, 1, 0. And I want all of the coefficients to work out so that the derivative's coefficients are 1. So if I think about what the derivative should be, I can think backwards to what the coefficients should have been, which is these light blue numbers that I came up with. It turns out that when you do this, the function you get is neither odd nor even. And there's just a definition for checking that, which is that you take the function you came up with and you plug in a negative x, and then you simplify. If the answer you get is exactly the same as what you started with, we would say it's even. If it's exactly the opposite, as in all the signs are flipped, it's odd. But in this case, some of the signs are flipped, like the second term here is negative, whereas it was positive before. And some of the terms are the same. So this would be a neither. The last one's pretty interesting. If you think about what it means to write a polynomial with a degree of 1 that has a coefficient of 1, it has to be this coefficient, and its derivative has to be 1. So the derivative at 2, it doesn't matter what you plug in, the derivative's answer should always be 1, which is why this is impossible. Last question. This was both the most straightforward of the free response questions and maybe the one that actually required the most work. I've got just about 2.5 minutes to get under the wire here if I'm going to keep this video under 15 minutes, so I apologize if I rush a little bit. Do pause the video if you need to kind of look at some of the algebra. The question gives us a piecewise function. It asks if it's continuous at the breaking point, which is pi over 2. And in order to check continuity, you check 3 things. You check the right-hand limit, the left-hand limit, and the actual x value. That's pretty easy. Just plugging in pi over 2. You would plug it in down here because that's where you get the equal sign line. And you just evaluate what you get when you plug it into the equation. On the top, this is the left-hand side of pi over 2. Imagine sketching a graph. The left-hand side is the left. So I use that equation for the limit on the left, and I use the bottom equation for the limit on the right. And it turns out that they all equal each other, so it is continuous. Next, it asks us to find an equation for the derivative. So you haven't done this before, but you can imagine that the derivative is just going to be the derivative of the top on that region and the derivative of the bottom on that region. So I got both of these derivatives. The top derivative, you'll notice, is a product rule, and that's because I had a product, x squared times cosine of 2x. There's also a little chain rule inside because the 2x is inside the cosine, and you can see that chain rule affecting the 2 out front right there. There we go. Now, there's the derivative. Calculating f prime of pi just means plugging in pi to this new function. Where would pi be evaluated? Well, pi is greater than pi over 2, obviously 3.14 and 3.14 divided by 2. So you would plug it into this. And this is one of those funky piecewise functions where the y value is always the same, no matter what the x value. So at pi, the y value, the output is just negative pi over 2. And then it asks, is it differentiable? Well, since you've already got the derivative function, we want to know if it's differentiable at pi over 2. You just calculate the derivative on the right hand and the left hand. Clearly, on the right hand, it's just pi over 2. On the left hand, you have to plug in pi over 2 into this expression, and you get, I've got the work off to the side here, something like this, which simplifies to this, which is pi squared, and that's not the same as what it was on the right, which is why it's not differentiable at that point. Okay, you have a quiz on Monday. It's going to look exactly like one of the 4 questions I just explained. Make sure that you study them all. Explain them out loud if that helps you. Rewrite them in your own handwriting if that helps you. Whatever you need to do, it's in your control. Have a good weekend.